Assalamu alaikum warahmatullahi wabarakatuh. Welcome to course 235 Electronics and Microcontroller. This part we are going to talk about Arduino. This is Ahmed Fawzi and I will be explaining the today's experiment inshallah. First let's identify what is Arduino. It is an open source electronic board, which means that I could use and utilize it to make different projects. It is programmed via computer. It is designed to implement many unlimited ideas and projects in a simplified way. For example, you could use it in your mechanical system to build a project where you could gather data from sensors like temperature sensors, pressure sensors, and so on, and you could manipulate different actuators like motors. Here's the advantages. It is cheap, easy to use, provide many accessories. It is also open source, which makes development on it much more faster. The uses of Arduino: there are many great practical applications such as projects to measure temperature, humidity, light, and so on. Projects to control the operation of devices and display the result on an LCD screen. Projects to measure the distance and avoid obstacles like self-driving cars and autonomous vehicles. Control home appliances via phone like smart homes and houses. Making a robot, for example, mobile robots or flying drones. Fire alarm. Projects to control robots via mobile phone or using Internet of Things, using a cloud on the internet to manipulate the home appliances like light, air conditioners, and so on. Automatic watering of crops. The uses of Arduino can't be limited because of their abundance, as you can use them in many other projects. Let's see this video. This video was to give you a better understanding of the uses of Arduino and how different people implemented into different projects, and it was very amazing. So it is time for you to make use of Arduino in your project. So I consider this part of the course is the craze. So you will be putted on the path in order to make so you will be putted on the path to understand. So you will be putted on the path to understand different concepts and to understand the fundamental concepts of Arduino. There are different types of Arduino board. First, Arduino Uno, Nano, Dio, Leonardo, Mega, Mini, and other things. We are going to utilize Arduino Uno in our course, which is simple. Arduino Uno has different characteristics. First, it is a microcontroller board based on Atmega. So here on the board of Arduino Uno, there is a microcontroller called Atmega 328, and it is responsible for the programming and storing. So in this course we are not going to deal with the microcontroller itself. We are going to deal with the board, which is called Arduino Uno. So it has different features. First, it has 14 digital input-output pins, of which 6 can be used as PWM outputs. So for example, if we have LED, which is a LED, it has two values, on or off. So we could put the LED here on these pins, which are 14 digital. And also we have 6 analog inputs. For example, here, if we have, for example, a smoke sensor or LDR, which is light detector, so we could put any analog inputs or sensors here in these 6 analog pins. Also we have 16 megahertz ceramic resonator, USB connection to connect the board with a laptop or the computer. We have also power jack in order to provide a power here to the Arduino board. This power takes about 12 volt. Also for communication we have IC SP header and a reset button, which is located here. There are different options for power supply in the Arduino Uno. First, we have the USB. When we connect the USB to our laptop or device, we could program the Arduino using this USB, and on the same time we could get the power from the USB itself from the device. So here it is a multi-purpose. We could get power supply to the Arduino board and also to program the Arduino board via this cable. Of course, this option we couldn't utilize it if we have a moving robot, so it is not possible to have a cable and to move behind the robot with a cable connected to your device. So there is other options. We could use adapter like here in the figure, which which will get the board from 7 to 12 volt using this header, or we could use a battery from 7 to 12 volt and connected here we have VN and ground, which are the two terminals of the battery. There's a question here: if I have 3.3 volt or 5 volt, can I get the voltage from the Arduino board? We talked about how to supply voltage to Arduino, but could I get voltage from Arduino to turn on, for example, a sensor or a small LED? Yes, you could take it from here. We have here 3.3 volt output pin, and we have also 5 volt output pin, and we have here 2 pins for ground and 1 here for ground. Here's a good figure. We have here the pins of digital board from 0 to 13. We have here ground board pin. We have here the reset button. We could press it when we want to reset our Arduino. We have here the USB port. We have the power adapter here. We could supply voltage to Arduino using VN here, which is located besides ground. We have here 2 pins ground beside this ground, and we could take power from Arduino, as we said last slide, from this 5 volt output pin or 3.3 volt. Also we have here analog boards from 0 to 5. Let's talk about inputs and output pins. These are the pins in the Arduino through which signals are sent or received. To make the picture clear, we can compare the subject to this figure. To illustrate what we have read here, we have here a speaker, and we have here ears, and the man here is speaking. So the ears is considered as input, and the sound that is getting out from the human here is considered as output. So let's illustrate in this slide. We have here different sensors and actuators. Let's identify which of them is input and which is output. For example, we have here motor. Motor is considered as output, like our legs. We have here ultrasonic or IR sensor, which looks like our eye. So it is considered as input. We have here a lighting LED, which is output. We have here potentiometer, which we vary here or rotate here the shaft, and we get different resistance, so it is input. So let's identify the pins type. We have 2 different categories. We have analog and digital. For example, digital, if we have here the lighting system, we could press this button and switch it on or off. So it means that we have 2 states, 2 values, either on or off, and it is represented by this signal. Here it is 0 right now. After that, when we open the light, so it becomes 1. After some time we close the light, so it returns to off and becomes 0, and so on, 0, 1, 0, 1, and so on. For analog, the story is different. The voltage vary with time, so it is not 2 value, it is different values. For example, it is right now 0, after some time becomes 1, 2, 3, after sometimes it decreases again, becomes 2, 1, 0, -1, -2, and so on. So The value is varying with time. Like, for example, if we have a light sensor, if the room is dark, so the sensor will give me small value, for example 0 or 1 and so on. And if there are some light in the room, so it values becomes greater, so its value becomes greater. Also, if we have a robot for avoiding obstacles, and it is provided by ultrasonic sensor which looks like our eyes, so the objective here is to maintain the robot in space distance from the obstacles and from any walls. So as we approaching the walls or the obstacle, so the value or the distance is decreasing. So for example, right now we have distance between the obstacle about 1 meter. After some time we become closer, and the robot gives us the distance about half meter, and so on, and until reach to small distance, for example 10 centimeter. So let's start right now how to program Arduino board. There is a software called Arduino IDE. So we programmed it using this free open source software which is provided by Arduino company. It could be obtained and downloaded from the official Arduino website using the following steps. First, we have to write www.arduino.cc on our web browser, and after that we search on it, go for downloads, use the version, for example Windows, choose the type of your device and your software that you are going to set up, for example Windows, and here you could download the Windows installer or a zip file. After downloading, you could run, and after running, the setup is very simple. After setup, you could open the Arduino IDE. Here is the interface. We have here different things. Here where we are going to write our code. After writing the code, we could compile and download using this button to download our program to the Arduino board. Here, if we have some error, it could appear here in this black area. First, we have to make sure after making our code to open the tools and open the board and choose Arduino Uno, and also open the serial board and choose which board we have connect the Arduino to our device, for example COM3, COM5 and so on. How to connect Arduino with a PC or a laptop. Connect the Arduino board to computer via the USB cable as this figure. After connecting the board, a message will appear on the right side informing that the board is connected to the port number as shown in the figure. For example, it is connected here to COM34. Open the program and click the Tools menu from the menu bar and choose. First, I have told you that you have to choose board first, and after that you have to choose serial port, which is COM35. So we are ready now to start our experiment. First part, we are going to use LED. We are going to make it flashing. How to make this possible? First, we are going to write the code and connect our circuit. First, here we have two main things in Arduino code, and it is repeated every time when we are going to make a code. First, void setup and void loop. Void setup, if we are going to define some things that we are connecting, like motors, LEDs and so on, different sensors, different actuators, we are going to define them here in void setup. Into void setup, we are going to define the pin and which type, is it input or output. Into void loop, we are going to implement our code, which is continuously repeated every time we start Arduino. For example, here we are going to use LED and make it flashing on off for some period of time. So we are going to write digital write 13, which is the pin that we have putted our pin connected to Arduino, and we have putted here comma and write high. So it means that our LED will become right now on for delay 1000, which is 1 second. 1000 millisecond equal 1 second, so it become on for 1 second. And after that I copied the same digital write 13, but instead of high I put low, so it will become off for 1 second. So it becomes on, off, and repeat inside void loop for infinity. So it becomes on, off, and so on. So to summarize, here's the slide. We have here pin mode. We write it to identify which port that I have connected my sensor or my actuator and so on. And inside void loop, I am putting the program or the algorithms that I'm going to implement and make it through using Arduino. Note that Arduino is sensitive to syntax errors. For example, here pin B is small. If you write it capital, so it will give you an error. Mode M is capital, so you have tried to write it in capital words. Output all are capitalized. High and low are all capitalized, so you have to notice the difference in the writing commands. And also here we are using parentheses and different types of brackets, so you have to follow the same structure. These are common mistakes in mode. If you write it all small, so it is wrong. Here digital write W is capital, high, all high is capitalized. We have made the first part, which was the coding. Right now we are going to connect the circuit. How to connect the circuit? We are going to connect our LED to 13, which is pin 13, and we have here a wire connecting pin 13 to the first long leg of the LED, and the second leg, which is the shortest, is connected to a resistor, and the other side is connected to the ground. So here we have a closed circuit. If we generate a signal on pin 13, so it means that the power will flow here, the current will flow inside the wire and open the LED and back again in the closed circuit. And if we write a code to on and off, like what we have wrote, flash and LED, so it becomes on and off for 1 second and repeat it forever. Here the importance of adding a resistor in series with this LED in order to not burn the LED. You are going to test different scenarios. Delete the first delay line in the code and run the code. What did you notice? And explain. Also return the first delay that you have deleted right now, make it back, and remove or delete the second delay line and run the code and explain what you have noticed. Please note that it is related to the frequency of the CPU clock inside the Arduino. As we have said on Arduino Uno features, it works on 16 MHz, which means that it gives us 16 million clock cycle per second. So it means that the CPU executes the bytecode of the program in that time. 1 over 16 MHz gives us 62.5 nanosecond, which is the period. 1 over frequency is the period. For the second part of this experiment, turning on 3 LEDs sequentially. Please note that this code is not complete. so you have to use it as a guide and implement what is missing. So here we identify only one lid, so there are other two lids you have to connect, so you have to put other two lines here, bin modes, and identify which port that you have connect. For example, 3, 4, and 5, and you have to put them as output. After that, inside void loop, you have to follow the logic. So it looks like a traffic light. To understand the concept here, we have here three different colors of LEDs. For example, we have red, yellow, and green. You have to open or make the first lid on for 1 second. After that, it becomes off, and the second lid will becomes on for 1 second. And thirdly, you have to turn off the two other lids and turn on the green lid for 1 second, and so on. It will be repeated sequentially. Used part here, we have three resistors, we have three lids, Arduino Uno, and the breadboard. Please note that when we are going to connect using breadboard, you could return to the first or the second video where I have explained the concept of connection using breadboard. For example, how to connect in series and in parallel. Here we are going to identify a new concept which is called variable. For example, here we identified the pins 2, 8, and 13. We have connected our LEDs on these pins, and in void loop we have to return the same pattern to 8, 13, and so on inside our code. So what will change in the code if we want to change the red lid input number to input number 3 instead of input number 2? For example, here I have connected my red lid into pin number 2. So if I want to change it and connect it to pin number 3, so I have to change each value of 2 inside the code, here 2, here 2, and so on. We have to change all of these 2's to 3, which is the new pin. So here's a new concept which is called variable. I will need to change the input number in the whole code, but what if I want to change all input for all LEDs? Modifying the code will take a lot of time, so there is an easier way, which is using variables. How to use variable? You have to identify, for example, here int, which abbreviation for integer. We have here red lid equal 2, which is connected to pin 2. We have int yellow 8, int green 13, and so on. So instead of using 2 here, 8 and 13, so I will use the variable itself. I will use red lid, yellow, and green, and so on. And if I want to change the connection, my connection pins, I will change it here in the beginning of the code, which is 2, 8, 13 only once, and no need for changing it throughout the whole code. Part 3, turning lid into two directions based on a switch. So we are going to identify here an input, which is a button or a switch. The switch has two states, for example, left and right. So if it is on right, so it will run the lids on one direction, for example, red, yellow, and green, and so on. But if I change my state here to the other side, so it should reverse the direction. So it will make the lighting from green, then yellow, then red. So you are going to use this as a guide. So you are going to put pin modes for the lid, for the button here, which is input, and pin modes for the other three lids. And here inside void loop, we are going to use x is a variable, and it takes digital read from the button which is connected to pin number 3 here. And we are going to put if condition. If x, which is the button connected to pin 3, equal high, so its value, for example, it is high, so it will going to implement the sequence of the code that you are going to implement inside this space. Else it will reverse the direction, and you have to flip the logic that you have put it here and put it inside else. So if else, it will going to if this value is true, if x equal high, so it will implement the code inside here. If it is not true, if it is low, it will going to else and implement the code inside else. Use the following code and figure. It is not complete. The figure is not complete and the code is not complete. So that you have to turn on the LED in one direction if the switch is off, and to the other direction if the switch is on. Thank you for listening, and I would like to thank also Engineer Omar Ahmed, and see you next lab inshallah.